The ISS is dying. NASA's scientists are feeling the pressure. There are just over 5 years left until the ISS retires, and yet they haven't seen a viable space station ready to take its place within that time frame. In this critical moment, NASA is turning to SpaceX, partnering with them to transform Starship into a space station, a project that could be their saving grace. Let's find out everything in today's episode. Every man-made structure and piece of equipment has a limited lifespan, and the International Space Station, ISS, is no exception. As we approach the end of the decade, when the ISS is expected to retire, the pressure to develop alternatives is mounting. Recognizing this burden, NASA has started planning for the post-ISS era. One of their main strategies is to lease space on private space stations once the ISS retires. To bring this vision to life, NASA launched the commercial LEO development program. Through this initiative, NASA has signed agreements and awarded contracts to multiple private companies to kickstart the development of these future space habitats. Specifically, Blue Origin and Sierra Space received $130 million to develop the Orbital Reef Space Station. NanoRacks LLC was awarded $160 million to work on the Starlab space station. Lastly, Northrop Grumman Systems Corp. received $125.6 million to build a free-flying commercial space station. Altogether, NASA has allocated $415.6 million to these companies to develop commercial space stations, ensuring America's continued presence in low Earth orbit after the ISS is retired. The issue, however, is that none of these companies have yet proven their ability to construct a fully operational private space station. According to recent reports, Axiom Space has hit significant financial roadblocks. Their plan to build a separate module and eventually an independent station seems to be faltering due to funding challenges. In another development, Northrop Grumman has decided to abandon its own space station project. And the Orbital Reef project, a once promising initiative led by Blue Origin in partnership with Sierra Space, has also encountered major setbacks. Sierra Space has withdrawn from the collaboration to focus on their own endeavor, the Dream Chaser. Meanwhile, Starlab, another private space station project developed by Voyager Space and Lockheed Martin, is facing its own hurdles. Despite backing from big names in the industry, the project appears to be moving at a slower pace than initially planned. While 2030 is still the target year for launching any new space stations, the current situation may push NASA to look for a backup solution sooner. As of now, there is no specific plan for a government-owned research lab after the ISS retires. This is where Starship could play a critical role. Could Starship itself serve as a space station? Absolutely. Under NASA's Collaborations for Commercial Space Capabilities 2, CCSC-2 program, SpaceX and NASA announced plans to work together on developing an integrated low Earth orbit architecture. This project not only involves Starship, but also incorporates other SpaceX programs, such as the Dragon spacecraft and the Starlink satellite internet network. It's a significant step forward, showing that NASA is seriously considering Starship's potential as a solution for the future of low Earth orbit operations. What's crucial is to view Starship not just as a rocket, but as a versatile platform with enormous transformative potential. As Elon Musk, CEO of SpaceX, has pointed out, with the same volume as the International Space Station, you could do what's happening on the ISS right on a Starship if you wanted to. This vision is gaining momentum, and Starship could very well be the key to maintaining America's presence in low Earth orbit after the ISS era. To understand why Starship is so well suited for the role of a space station, we need to look at its impressive specs. Starship, originally designed to carry humans to Mars, in its current standard version, can haul over 100 tons of cargo and has enough room for 100 passengers on a journey that could last up to 6 months. This means it's already equipped with complex, long-term life support systems, a critical requirement for any space station. In terms of size, Starship is truly remarkable. Its standard payload bay has an external diameter of 9 meters, offering the largest cargo space of any launch vehicle either in existence or development. Estimates suggest that the usable volume inside Starship exceeds 1,000 cubic meters, a massive space, large enough to fit the entire Eiffel Tower if it were disassembled. This sheer capacity has scientists and engineers excited about the possibility of using Starship as a space station. While Starship wasn't initially built to be a space station, its volume surpasses that of both Starlab and Orbital Reef. compared to the ISS, which has an interior volume of less than 1,000 cubic meters. Starship could provide equivalent or even greater workspace and living areas. This opens up the possibility of creating spacious laboratories, comfortable crew living quarters, and even room for commercial and space tourism activities. Despite Starship's impressive interior volume, there's one undeniable fact. About 2/3 of its current structure is unusable space. Most of this is taken up by engines, plumbing, and especially propellant tanks, which alone occupy over half the spacecraft's volume. This raises an intriguing question. Is there a way to maximize Starship's full potential as a space station? Many experts and space enthusiasts believe that SpaceX might gradually repurpose remaining areas, like the propellant tanks and engine compartments, to convert them into habitable space. If this happens, the usable volume could triple, offering over 3,000 cubic meters of living and working space per Starship. That's a staggering figure, unlocking endless possibilities for future space design and utilization. However, this conversion is no simple task. It presents significant technical challenges for SpaceX. As of now, it's still unclear how SpaceX plans to make this transformation. Got any ideas on how they'll do it? Comment below. For Starship to function as a standalone space station, it would need many of the same capabilities as the International Space Station, ISS. This includes docking capabilities for crew transport vehicles, radiation shielding, protection against the extreme temperatures of space, and the ability to provide stable, long-term power. While these requirements seem complex, with the technology and experience SpaceX has amassed, they are in a strong position to make these adjustments in a relatively short time. A great example of SpaceX's ability to modify Starship for specialized missions is the Starship HLS. This version of Starship was designed specifically for NASA's Artemis program, which aims to return humans to the moon. Starship HLS has already proven that SpaceX can adapt its Starship platform to meet the unique needs of a space station. Let's take a closer look at the adjustments SpaceX has made with Starship HLS. First, there's the power system. Starship HLS is equipped with large solar arrays capable of providing stable, long-term power. The successful integration of these solar panels into Starship HLS shows that SpaceX could apply similar technology to a space station version, ensuring a reliable and sustained power supply. All they'd need to do is equip Starship with larger solar panels to make it fully functional as a space station. Secondly, there's the docking capability. Starship HLS was designed to dock with NASA's Orion spacecraft. If Starship HLS can dock with Orion, Starship can certainly dock with other vehicles as well. SpaceX has solid expertise in advanced docking systems, precise sensors, and sophisticated control software. Crew Dragon has docked with the ISS smoothly dozens of times. While a space station wouldn't need the same powerful propulsion system as Starship, it would still require smaller thrusters to adjust its orbit and maintain orientation. SpaceX's experience in developing and refining propulsion systems for Starship HLS could easily be applied to create an effective orbital control system for a space station. Using Starship as a space station can be considered as a potential solution to address the growing international competition in space exploration. This situation was recently highlighted by Congressman Brian Babin, chairman of the House Space and Aeronautics Subcommittee. He pointed out, when the ISS was built, it was the only facility of its kind. Today, the Chinese Communist Party operates its own space station, which has hosted taikonauts, Chinese astronauts, in low Earth orbit, LEO, since 2021. This marks a significant turning point in the space race, as China has successfully established its independent presence in orbit. Moreover, Babin also warned that China is actively seeking international partners to conduct research on their space station. This could lead to a concerning scenario. If another station is not operational by the time the ISS retires, China's station may become the only human-occupied facility available for research in LEO. This is a situation that could seriously impact the U.S.'s scientific and geopolitical standing in space exploration. SpaceX's development of Starship not just as a transportation vehicle, but as a potential space station, combined with its participation in the Artemis program and plans to build a lunar base, is creating a comprehensive pathway toward the ultimate goal of colonizing Mars. This strategy not only helps SpaceX accumulate the necessary experience and technology, but also contributes to maintaining the USS leadership in the new space race as competition from other nations, especially China, continues to intensify. Haven 1 will be one of the most minimalist space modules, yet it's packed with scientific and practical purposes. Its cylindrical shape is a common design choice for modern space station modules, not only optimizing interior space but also ensuring structural integrity under the immense pressures and stresses of the space environment. With the tension caused by microgravity and external pressure, the cylindrical form provides optimal strength, allowing the module to withstand the harsh conditions of space. At the top, Haven 1 features a rounded nose fitted with an observation dome. This dome window offers breathtaking views, suggesting that Haven 1 is not just for research, but also for leisure. After all, this is a private space station, and its goals will definitely encompass space tourism. A key feature to note is that Haven 1 has only one docking port, located at the center of the module's rear. This compact, circular docking port is equipped with multiple sensors and mechanical latches to ensure a secure and precise docking process. It allows only one spacecraft to dock with Haven 1 at a time, meaning the station can accommodate a maximum of 4 crew members per visit. This makes Haven 1 an ideal choice for mid-scale missions, offering a unique, straightforward, and efficient experience. In terms of size, Haven 1 boasts a diameter of 3.8 meters and a height of 10.1 meters. This gives it an interior volume of about 80 cubic meters, ideal for crew habitation and conducting research. The module is expected to weigh around 14 tons, though relatively compact, essentially a mini space station. Haven 1 has been perfectly optimized to fit within the payload capacity of SpaceX's Falcon 9 rocket. Power for Haven 1 is sourced from large solar panels mounted symmetrically on either side of the module. These panels capture energy from multiple angles as the station orbits Earth, capable of generating up to 15,000 watts of electricity. Haven 1 will orbit at an altitude of approximately 310 miles, nearly 500 kilometers, above the Earth's surface, slightly higher than the International Space Station, ISS. VAST has boldly declared that they plan to launch Haven 1 no earlier than August 2025. Once deployed in low Earth orbit, 4 commercial astronauts will be transported to Haven 1 by SpaceX's Crew Dragon, and will spend about 30 days on the station before returning to Earth. It's a bold plan with an incredibly fast timeline. Jed McCaleb, founder of VAST, admitted in an interview with Ars Technica, "It's a super aggressive schedule, but we have a clear path for how we're going to get there." Founded in 2021, VAST leaped into the industry with an incredibly optimistic timeline. With fewer than 200 employees currently, building a fully operational, human-rated space station within a few years is nearly unbelievable for a startup. So why are they so confident? Even though there's been no official word on SpaceX's involvement in the Haven 1 project, it seems SpaceX's role might extend beyond merely launching Haven 1 and ferrying astronauts with Crew Dragon. Looking at the design of Haven 1, I immediately noticed significant similarities between this module and SpaceX's Dragon XL, a proposed upgrade of Crew Dragon that SpaceX has announced but has yet to officially debut. Dragon XL was initially intended to support cargo missions to Gateway. However, SpaceX has been extremely tight-lipped about the progress of this variant, and many believe that SpaceX may have shelved or redirected the Dragon XL project towards other goals. The striking resemblance between Haven 1 and Dragon XL suggests that VAST might have leveraged some of SpaceX's research and development from the Dragon XL project to create their own module. This could explain how a relatively new player like VAST is making rapid strides in an industry where hardware development can take years or even decades. Take a look. The diameter of Haven 1 is strikingly similar to Dragon XL's, around 3.7 meters, which is also the diameter of the second stage of the Falcon 9 rocket. Industry rumors suggest that SpaceX planned to use the production tools from the Falcon 9's second stage to build Dragon XL. Maybe the design and development process for Dragon XL has seamlessly been transitioned into creating Haven 1. The renderings of Haven 1 reveal a cupola dome window that closely resembles the one SpaceX used on its Dragon spacecraft during the Inspiration 4 mission. This is a significant detail that highlights a close technological link between SpaceX and VAST's module. In fact, the connection between VAST and SpaceX goes beyond mere design similarities. The senior leadership and advisory team at VAST include numerous former SpaceX executives. For instance, Garrett Reisman, SpaceX's Director of Space Operations, brings a wealth of experience in managing space missions and an intimate understanding of SpaceX's technology development processes. Then there's Hans Königsmann, former Vice President of Mission Assurance at SpaceX, who played a crucial role in ensuring the success of SpaceX's rocket and spacecraft missions for many years. We can't forget Will Heltsley, a leading propulsion expert who was Vice President of Propulsion at SpaceX for 12 years. His extensive experience in propulsion systems is a significant asset for VAST. And Jake Burnett, who played a direct role in testing and deploying Crew Dragon missions, including Demo 1, Demo 2, Crew 1 through Crew 7, Inspiration 4, and Axiom 1 and -2, is also a key member of Vast's team. With nearly a decade of work in Dragon's production testing department, Jake has deep insights into the critical systems of the spacecraft. With such a powerhouse team behind it, Vast's approach to developing Haven 1 certainly has a strong foundation. The names mentioned are just a few of the key players who have transitioned from SpaceX to Vast. This strengthens the possibility that SpaceX is not merely supporting the transportation and launch of Haven 1, but could also be behind many crucial aspects of the station's design and development. If the hypothesis that Haven 1 is built on the Dragon XL foundation holds true, it would explain why Vast has made such rapid progress in developing a space station. What we're seeing with Haven 1 might be the result of leveraging the research and development from Dragon XL, effectively turning those efforts into a fully fledged space station. This not only allows Vast to save considerable time and resources, but also helps SpaceX maximize and utilize previously developed technologies. You might think Haven 1 is just another space module, but it's far more significant than you might imagine. The most exciting aspect of Haven 1 is that Vast plans to conduct the world's first artificial gravity experiment on this space station. Specifically, Vast will create a sensation of gravity in space by using centrifugal force, a concept usually relegated to science fiction or theoretical experiments. When an object spins around its axis, centrifugal force pushes everything inside away from the center, creating a sensation akin to gravity, even though you're still in a weightless environment. Haven 1, with its cylindrical design, is meticulously configured to test this phenomena, serving as a groundbreaking platform for experimenting with different levels of artificial gravity, ranging from 0G, zero gravity, up to 1G, Earth's gravity. This opens up an extraordinary capability. Scientists can conduct experiments under varying gravitational conditions, like the Moon's gravity, 0.165 G, Mars' gravity, 0.376 G, or even customized gravity levels of their choosing. These experiments aren't just about understanding how physical and biological factors behave under different gravity levels. They also pave the way for exploring the potential for living and working on other planets, from testing equipment and materials to studying biological responses. All of this research is crucial for preparing humanity for long-term planetary exploration missions. Especially, Haven 1 is not just Vast's first commercial space station. It's also a strategic proof of concept. The existence of NASA's Commercial LEO Destinations (CLD) program is a crucial factor here. This program aims to develop commercial space stations in low Earth orbit. With what Vast is doing, it's highly likely they will join the CLD program once Haven 1 is completed. Scheduled to host only 2 visits from SpaceX's Crew Dragon spacecraft, Haven 1 is designed as a stepping stone, a laboratory in orbit where Vast can learn and refine their approach. Because Vast's ambitions don't stop with Haven 1. Their ultimate goal is to build a space station with an enormous artificial gravity capability, with an internal volume of up to 3,500 cubic meters. That's 3.5 times the volume of the International Space Station. This bold concept could revolutionize how we live and work in space. In reality, Vast has embarked on this ambitious plan, clearly pushing the boundaries further than most private space companies can even imagine. It's incredibly ambitious and exciting. But this raises a big question. Could SpaceX be quietly supporting Vast's efforts to develop this massive artificial gravity space station? Do you think SpaceX might also be secretly working on their own colossal private space station? Share your thoughts below. All right, that's it for today. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more in-depth looks at the latest advancements in space technology. Thanks for watching, and I'll see you next time.